This unit is Use Numbers, Currency, and Percentages in Formulas. My name is Jeff Alhadeff. Welcome to join me as I work my way through this unit. If I come across something that seems tricky, or at least I find tricky, that I then got some clarity around, or something that seemed like it was missing, whatever it is, I'll link to it in the description below, so you could jump there and find those sorts of gotchas. If not, you're welcome to join me as I work my way through this unit. I should warn you, though, this says the time estimate's about 25 minutes. The first unit time estimate was about 20 minutes, and it took me an hour and a half over 2 days to get through. So you don't have to watch the whole thing. You just jump to the part that is helpful, or whatever. Okay. After completing this unit, you'll be able to describe what the number, currency, and percent formula return types are. That's good. Explain the difference between the number, currency, and percent types. Describe use cases for formulas with number, currency, and percent types. I see a repeating theme here. Create a formula for using the number, currency, and percent types. Okay, this is going to have to do with number, introduction to number. It's not funny, I don't know why I'm laughing. Introduction to numbers, currency, and percentages in formulas. When most people hear the word formula, don't you read? What do you think of when you think formula? You think formula. It's what you give babies if you're not nursing. That's formula, if you ask me, okay? They imagine something that involves numbers. If I just say formula, I would never call it, that's a math problem. I am such why am I doing this to myself? Okay. Well, that's not always true with formulas in Salesforce. Wait, was it? It's something that involves numbers. Well, that's not always true with formulas in Salesforce. A few data types are based on numbers. The most simple of these types is the number type. When you create a formula field that returns a number, you can specify how many decimal places your number has, from 0 up to 18. That's helpful because... why? Exactly? I mean, if you want to specify so it's a shorter number so it's easier to read or more accurate, those are sort of the trade-offs, I think. I always like benefit statements. Numbers can be positive or negative. Not good for you, bad for you. Math. Yeah. Integer. Or decimal. I'm so embarrassed I'm doing this right now. A whole number. That's not a fraction. Okay. Just own it. Numbers work well for measurements, such as temperatures, lengths, and populations. Currency, however, has its own data type. A formula that returns currency data is similar to a number formula, except that currency values come with a currency sign built in. Note, custom formula fields that use currencies aren't associated with any particular currency. If your organization has multi-currency enabled, the result of a currency formula displays in the currency of the associated record. Okay, so when in doubt, go with what the record says. Percents are also their own data type, a number with a percentage sign attached. Woohoo! A percent is stored as a number divided by 100, meaning 100 is represented as 1, 90 as 0.9, and so on. You know what? I've seen this in some formulas up until now, and I've sort of wondered about that, so that's helpful to know. So 0.9 is 90%. 1 is 100%. You can mix and match these numerical data types in formulas, but keep their differences in mind. And remember, no matter which type you're using, the value your formula returns can't be more than 18 digits long. including the digits before and after the decimal point. Okay. I remember that. Sounds like that's advice to live by. Son, my dad taught me. Okay, moving on. Formula return type. Characteristics. Number. A positive or negative number, either integer or decimal. Currency. A number that comes with a currency sign. Percent. A number that comes with a percent sign stored as a number divided by 100. Common number, currency, and percent functions and operators. When you work with numbers, you use certain functions and operators often. Mathematical operators. The most used operators in formulas that return a number, currency, or percent are the math signs that you've been seeing since your earliest arithmetic classes. Operators, the most used operators. Okay. Operators are not the people that you press 0 to reach. They are little symbols that you've been seeing since your earliest arithmetic classes. Do people really call it arithmetic? What's the difference between arithmetic and math? The branch of mathematics dealing with the properties of manipulation of numbers. What's math? The science of numbers and their operations. Interrelations, combinations, generalizations, abstractions and of space, configurations and their structure, measurement, transformations, and generalizations. And my brain just heard womp 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 womp. Oh, but there's a cute kitty. Okay, moving on. So arithmetic is specifically about numbers. Math is generally other stuff. You can add the plus sign, subtract, the subtract sign, multiply, yeah, and so on. Numerical values. You can also use exponential, not exponential, exponential. In formulas, these operators work just like they do on a calculator. Formulas follow the order of operations, and you can group operations in parentheses. Order of operations. Shoot, I don't remember that. Come on. In mathematics and computer programming, here we are. The order of operations is a collection of rules that reflect the conventions about which procedures to perform first in order to evaluate a given mathematical expression. Come on. Why are you opening in that window? I want you open. Let's see if we can do this. Okay. Collection of rules that reflect conventions about which procedures to perform in the first order to evaluate a given... What did I just click on? For example, in mathematics and most computer languages, multiplication is granted a higher precedence than addition, and has always been this way since the introduction of modern algebraic notation. Thus, the expression 2 plus 3 times 4 is interpreted to have the value of 2 plus 3 times 4 equals 14, not 2 plus 3 times 4, which would equal 20. With the introduction of exponents in the 16th and 17th centuries, they were given precedence over both addition and multiplication and could be placed only as a superscript. That's a really cool script. It's super. To the right of the base. The base, that's the number. It's all about that base. Thus, 3 plus 5 to the second equals 28. because you do 5 times 5 is 25, plus 3 is it, yeah, and 3 times 5 to the second is 75, because 5 times 7 is 75. Okay, fine. These conventions exist to eliminate ambiguity while allowing notation to be as brief as possible. Where it is desired to override the precedence conventions or even simply to emphasize them, parentheses, sometimes replaced by brackets or by braces for readability, can indicate an alternate order or reinforce the default order to avoid confusion. For example, 2 plus 3 times 4 equals 20 forces addition to precede multiplication, and 3 plus 5 to the second equals 64, because then you get 8 times 8, 3 plus 5, yep, forces addition to precede exponentiation. So it's sort of like, like a base way of it operating, and then the parentheses overrides those rules. So it's exponents, multiplication, addition, subtraction. I feel like there's a cute mnemonic to remember this, though. Khan Academy. Oh yeah, PEMDAS. PEMDAS? DAS? Parentheses, exponents, multiplication, division, addition, subtraction. In the UK, they say BODMAS. BODMAS. They probably say, right? It's got to have a British accent. Now, children. Follow BODMAS. And then you could have your, okay. Formulas follow the order of operations, okay, and you could group operations in parentheses. You can use the greater than or less than, which I struggled mighty with making sense of. Is yesterday greater than or less than today? Answer, it's less than. God, that was so hard in the quiz that I did in the previous lesson. Oof. I don't know why that broke my brain so bad. Less than or equal, or greater than or equal, to compare two numerical values. To check if the numbers are equal, use equal. See, it's funny because normally you think of the equal sign as meaning like this equals that, but here you're using it to check if the two numbers are equal. Like, just look. No, but you're telling a computer, and computers are fundamentally stupid. Okay, to check if two numbers are not equal, use do not equals, which can be written either as, oh, is it equal? Or, why would two brackets do this? Sort of like a, whatever. It's not a facial expression, Jeff. It's math. Moving on. Mathematical functions. The formula editor also provides some other mathematical functions. The function round rounds the numerical value that you give it. It uses the round half up rule, meaning that halfway values are always rounded up. For example, 1.45 rounds to 1.5 and 1.43 rounds to 1.4. Oh, I thought 1.45 would round to 1. Great. Are we going to whole numbers? What? Right? Okay, so the function rounds the numerical value that you give it. It uses the round half up rule. So this was a little confusing to me because I would think that this would be, instead of going from 1.45, it would go back down. And so apparently it follows the decimal. So at least goes to the first decimal. Not to the next whole number. And I'm just curious, like maybe if it was 1.453, it would just round to 1.45. 4, right? Round that last one down. Maybe. I don't know. So this round folk guy is confusing. If you have ideas, let me know. And I apologize. I think I had my microphone too close to me. So like when I got excited, I was like blasting your ears off. That's not cool. The currency formula uses round to calculate a discount and round it to... Dude, if I just kept reading. And round it to 2 decimal points so that it's a proper currency amount. Round, price, custom, field, minus, price, times discount, all these custom fields, to the 2. Okay, so you can use built-in operators to perform several other mathematical functions like absolute value, ceiling, or floor. To learn more about mathematical functions, if you really want to, although they come in so darn handy. You see formula, operators, operator, how may I help you? Yes, I'd like some formula, please. My baby's hungry. And functions in Salesforce Online Help. Where would I put such a formula? I think I would put such a formula as a field on an object. Opportunity object, maybe. Order object. Could be anywhere, I guess. We got battle stations in there. Be nice. Today's a great day to smile. Thanks, I know. Did I do that? I think I did that. Or your sense of humor comes back to bite you. Darn it, I am happy. Leave me alone. Supplies. Group, chatter, reports, dashboards, campaigns. Orders. Where would orders be? Okay, well, you have an opportunity. Those are already round numbers. High probability opportunities, all opportunities. Do I have anything with some funky numbers at the end here? No, we don't. Could I change something? Let's say this is going to be 45,000.5678. Oh, well, it just rounded it up for me. Why is it doing that? I mean, that's happening on the opportunity object, on the amount field on the opportunity object. This was talking about the price. I'll just look for price. I don't know. So, if... One second. Okay, so I was curious, like, where would you use this? Like, if I actually wanted to try to, like this is a nice formula, but if I wanted to test it out, and I don't know where to do that. I mean, there's not like a price field there's an opportunity object, which on that has an amount, but I didn't see it. So, and I tried editing the amount field, like, if you go anything past validation rules getting back to me. I just want to update this. Okay, I get it. Push it out of ways. Updated. Okay, anyhow. Moving along. I don't know where this goes. Use numbers, currency, and percentages and formulas. You can use the number, currency, and percent types and formulas in many different situations, from calculating the percent commission on a sale to totaling annual revenue or profit. Here we go. In setup, use the quick find box to find the object manager. There's a couple of ways of doing that, but we just click on it. Click account, fields, and relationships, and new. Is price in here? No. New. Select currency and click next. Currency. Click next. In the field label, enter principal. Field name populates automatically. Down there, length 18. In decimal places, enter 2 because this is a currency amount. We want 2 digits after the decimal point. Change length to 16. Oh, in decimal places, do 2. Okay. And length, do 16. Aha, I'm so smart, because if you want the, doesn't length number of digits to the left? Right. Okay, so since you want, so length is always number of digits to the left of the decimal. Okay. And decimal places is number of digits to the right. Altogether, it equals 18. I wonder if I put in like 20 here, would that not save? Do I get an error rule? Ha! Good, I do. Length must be less than or equal to 18 if I put in 18. Now, there we go. The sum of the length and decimal places must be an integer less than or equal to 18. I would have liked to have seen that error the first time. I don't know how to correct that. Where am I going? Just curious. Seeing what happened. Okay. In decimal places, enter 2. Okay, 16. Click next, and save. Okay. Next, and save. We'll use the principal. We'll use principal to conditionally calculate an interest rate that we can use to calculate the amount of compounded interest on the account. That just didn't sound like English at all to me. We use principal. Which principal? My kid's school principal? Do unto others as others would do unto you? What principle are we talking about here? To conditionally calculate an interest rate that we can then use to calculate the amount of compounded interest on an account. Is principal a field? Huh. Huh. Hey. God, I'm so dumb. That's the field I just created. Right? Enter principal. Word principal. God, such an idiot. We'll use the principal field you just created to conditionally calculate interest. Just help me out a little bit. It's the end of the day. Just a little bit. Oh boy. Calculate percent interest. For this account, let's say the principal balance is below 10,000. The interest rate is 2% yearly or 0.02. If the balance is between 10 and 100,000, the interest rate is 3 or 0.03. If the balance is over 100,000, the interest rate is 4% or 0.04. Given principal. What does given principal mean? That's not English. Given principal. We have delivered the principal. He is in your control now. Use the if to decide on the appropriate interest rate. Okay. In the Object Manager, click the Account, Fields and Relationships, click New, click Formula Next. In Field Label, enter interest rate. Okay, here we go. We got this. Fields and Relationships. This is on the Account object. Click New, click Formula, click Next, click in Field Label, enter interest rate. And is this a select percent and leave the decimal places at the default 2. Next. Click Next, enter the following formula. Okay. I don't want to do it this way though, because copying and pasting would just be way too easy. Let me think this through. If principal, let me see if I can do this without. If principal is less than 100,000, if the balance, so the balance is the principal. That's the amount of. Okay, I'm in the middle of trying to do this formula, and if you're getting a little confused about principles and such, I also was, and I wish that what we did here was we said, okay, we're going to help you calculate the percentage of a mortgage, what the rate should be, based off of the value of the principal. A principal is the amount that a person takes out when they take a loan. Not everybody takes a loan out on a house. I don't know that everybody knows what a principal on a loan is for a home. Like if you rent, like you don't, I don't feel like it's a universally known thing, and I just would have helped set context for this a little bit better. So that's what's going on here. Principal. When you make a loan, you put a down payment. The rest is what you borrow, and that's called the principal. That's what you have to pay back. And that's why it sometimes says the principal balance is shown as below, and then here we just say if the balance. It doesn't say if the principal balance, which might throw you for a little bit of a loop. It did. It's just like a little confusing to me. Okay. Fine. I'm in the middle of trying to write this formula. Let's see how I'm doing. If principal. Okay. I'm just looking at this bottom part here and trying not to look at the rest. Good. If principal C is between, so greater than it's 10,000. Greater than 10,000. And less than 100,000. Then 0.03. And if that's 1,000,000. Let's see if I did that right. No, I didn't. Let's compare what I did and what it said I should have done. If principal C is less than 10,000, then, oh, do you have to have the zeros in there? Okay. If you have to do capitalized? Oh. Oh. Okay. So this is an if-and statement. If principal C is less than or equal to 10,000 and principal is less than 100,000, then do 0.03. If it's outside of that, if it's anything else, if then else, then do 0.04. Okay, happy I thought it through, even if I messed up. Note, our if statement has one gap. Although currency amounts can be negative, we're assuming that principal C is positive. If it isn't, this account is in trouble. Yeah. Well, if the amount's negative, then the bank would owe. If it's negative, then the bank would owe the person money. And it might be pretty important to be able to identify that. Can you imagine if the banks owed people money? And there was a mistake in a formula and it just went undiscovered, and banks just accidentally were holding on to tons of people's money without letting them know. You could see the congressional reports already. Somebody forgot to write a faulty formula that didn't account for negatives. Okay, now we have a principal amount and an interest rate, everything else necessary to calculate the accumulated interest on an account. Calculate accumulated interest on an account. We're going to create a formula that calculates interest on an account using principal, number of years that the account has been open. Luckily, there's a mathematical formula. Oh my gosh, I'm like not even halfway through. I gotta stop. Okay, picking up where I left off. Calculate accumulated interest on an account. We're going to create a formula that calculates the interest on an account using principal and the number of years that the account has been open. Luckily, there's a mathematical formula for calculating the account's interest over time. A equals PE raised to the power of RT, which uses the following variables. Okay. Variable P is the principal amount of money in the account. E, the mathematical constant of 2.71828. I'm not going to read the rest of that out loud. R, the annual interest rate of the account. And T, the number of years the account's been open. I don't know why. I don't know what this E, I mean, why is there this mathematical constant? I don't understand what that's doing there. Now we just need to adapt the formula to fit our fields. To start, insert the principal in the formula editor. We want to multiply principal by E raised to the power of the interest rate. Multiply the number of years the account's been opened. We can do that with the Exp function. Exp number returns E raised to the power of number. Okay. For the interest rate, insert the fields we made earlier. Interest rate C. To find the number of years the account has been opened, subtract year started, the year the account was opened from today. A built-in function that returns the current day. Because year started is a text value, you first have to convert it to a number using value, which takes a text string. That returns a number. We also use the function year, which pulls the year from the date, in this case the current date, returned by today. This gives us our final function. Principal, the custom principal, time raised to the exp. What does that do? We want to multiply the principal to the by E raised to the power of the interest rate. Exp number returns E raised to the power of number. Times year today minus value year started. So it was principal times E raised to the power of R times T. So I'm going to take year today, the annual interest rate, pausing. So I'm confused because I don't remember where I did this. Accounts on the account object, maybe. I'm picking it back up and it's been a day. Field and relationships. New, select formula, I click next, interest rate. So there should be an interest rate one. Okay, in the object matter, click account, field and relationships, and click next. Go to account, field and relationships. I thought I already got down here. 1 second. Well, one of the nice things about recording yourself is when you mess up, you've got it on video. So you can go back and see what you messed up on. So I didn't actually finish this process. I didn't click next and then finish it. So let's try that again. In the object manager, click account, fields relationship new. Click %. Right, select formula, then click next. Right, it's a formula. In the field type, enter interest rate. And this is the type %, which shows 2 down here. I'm going to click next. We're going to copy the formula and enter this in here. And this is going to be saying that if the principal is this, then the interest rate's that. If the principal is this, is greater than or equal to 10,000 and the principal is less than 100,000, then the interest rate's 3%. If it's anything else, which only can mean if it's greater than 100%, 100,000, then the interest rate's 4%. Okay, so one of the things that we're sort of missing here is, click next, next, and done. So, and save. Okay, great. Like we missed that part. Calculate accumulated interest on an account. Now that we've going to create a formula that creates interest on an account, so that means, we're going to do it on the account object using principal and this number of years that the account has been open. Luckily, there's already a mathematical formula for calculating an account's interest over time. It's just A equals PE to raised to the power of RT, which of course is very straightforward to all of you. And that's just these variables. And the mathematical constant of 2.78128128484590 I don't think I got that right, but that's fine. Anyhow, so we're going to now adapt the formula to fit our needs. We're going to insert a field and insert the field principal. To start, insert the field principal in the formula editor. Do I have this here? To start, insert the field principal in the formula editor. We want to multiply principal. Oh, no, this means this. I don't know where I'm doing this formula editor. Let me just create a new one. Why not? Insert the field principal in the formula editor. So I'm going to create a new field. We're going to create a formula for it. We'll call it accumulated interest. And I think this is going to be a number. Well, it's actually going to be a currency, right? The interest on an account. How much interest the account has accumulated over time of paying back a loan, so that's going to be just a number. And this is our formula, because we're going to start off with our principal value times exp. I don't really understand what the exp function does. Returns e raised to the power of a given number. Oh, okay. So exp actually, okay, so the exp function returns e raised to the power of a number, which I know that's what it said, but for some reason I needed to see it over here for it to make sense to me. So e is that mathematical constant. I don't understand why that mathematical constant's there, but that's probably a math issue, which is beyond the scope of this module, but I don't really understand that. I'd like to understand that. Okay, so that's so principal times exp, so this is then e times the interest rate times t. And t is the number of years the account's been open. And the way we figure that out is by multiplying the year of today minus the value that the year started. So what year is it today? When did it open? That's our t value. Cool. And now that you've entered your function in the formula editor, you can go ahead and click Next. On the field security page, click Next, Next, and then Save to finalize your formula. So, did I am totally confused, because this seemed to be the formula that got it added onto the interest rate. But there was never instructions here that said create an accumulated interest field on an account. But it seems to have done so. So I am just befuddled. Absolutely befuddled. But we're going to go ahead with it anyhow. Can I see this on an actual account? Okay. There's the interest rate. And there's accumulated interest. If principal, where's the principal? Principal. Is there a principal value associated with this? Oh, what is this? Oh, here it is. Principal. So principal is 0. If principal is blank, I think that's what we need to do. If principal is not blank, then you do this function. But if it is blank, then you don't want to do this function. So I guess the problem I'm seeing here is the interest rate is showing up at 2%. And since there's no principal, it makes no sense that the interest rate's 2%. It's just firing because the formula was written incorrectly. Okay, so the problem I was getting was that if the principal is empty, I was seeing an interest rate showing up here, which doesn't make any sense because there shouldn't be an interest rate of 2% on no principal. It just looks weird. So here's how I modified the formula after much back and forth, and I'm not happy with this. I feel like I did this sort of dumb. I did if principal is 0, then just do 0. And then, if it's not, so then check to see if it's less than 10,000, and then do 0.2. So then the rest of the formula. That's what I did. That seems to resolve the issue. If I look at pyramid construction, should be able to change this principal now to, let's say, interest rate's 4%. And that, if we do 10,001, it should show up here at 3%. If we do 2%, and if it's 0, it should be 0. So that helps a little bit. If it's blank, like just no value, it's still saying 0 there, which is good, I guess. Yeah. All right. Send me that. I mean, I would rather see just nothing here. I would rather figure out how do we write this formula so we only run this test if principal C is not blank. And try as I might, I couldn't figure it out. If you know how to, please let me know in the comments. I'd so appreciate it. Otherwise, time to move on. Okay. Number of formula examples. Oh, I never actually put this in here. So this would be on our fields and relationships. This was the field that I created. What would I call that? Accumulated interest. Oh, here it is. Okay, that works. Did I actually check this? See it in the wild here? Accumulated interest. Oh yeah, there it is. So then this should calculate the year that the loan started. Let's see what that is. Okay, we're going to move on. Given the margin in percent, numbers of items sold, and price per item, this formula calculates gross margin profit. Okay, so I think there's just some of these we can't actually plug in because we're just learning the formulas sort of in abstract. Margin percent, item sold, margin item, fine. Margin percent times the number of items sold times the price. Yeah, that would give you your gross margin profit. Because this is, so if you made a 10%, if you sold so if the price of the item was $100 and we had 10% margin, so you made $90 in each one, and if you sold 10 of them, you made $900. Okay, this currency formula calculates a commission, assuming a max commission of 500. Given the existence of a custom percent field commission and custom currency field sale, this formula returns the lesser amount between 500 and the percent commission multiplied by the sale amount. So min, pick the smallest one of 500, or the sale times the commission rate. Maybe that's what that is. Given the existence of a custom percent field commission, so we're going to assume these fields exist and assume that there's a custom currency field sale. So then that's what this formula would do. But they don't right now, so we're not going to test it. Number formulas are helpful for doing basic unit conversions. This formula converts Celsius temperatures to Fahrenheit. Oh, United States, why are you so annoying to have to do something different than the rest of the world? Please. Now this one converts miles to kilometers, which you shouldn't have to do. Common errors with number formulas. Dividing by 0. The same rules of mathematics you're used to. I'm not used to any rules of mathematics. Apply when writing number-based formulas. If your formula divides by 0, you get an error later on. When you're dividing two numbers, ensure that the denominator is never 0. It's especially important to think about dividing by 0 when you're dividing by another field whose value can change. If you want to divide by a number that might be 0, use an if statement to guarantee that you don't encounter an error. For example, this formula calculates the revenue per employee on an account by dividing annual revenue by number of employees. If there are 0 employees, you've got a bigger problem than figuring out how much revenue you have. Right? The formula returns 0 instead of running into an error. This formula error is the least of your worries if you have a business and you have nobody employed. Like, don't figure this out. Okay, but anyhow, this formula says if number of employees is not equal to 0, then annual revenue is divided by number of employees is 0. So if this is true, do this calculation. If not, just put a 0. Okay, checking null fields. Oh, hey, I was trying to do this earlier. It might be tempting to check if a field is empty by using the equals or not equals operators to see if it equals null, but the best practice is to use the built-in function ISBLANK. ISBLANK takes a field as an argument. I wish that was better English. Takes a field as an argument. Darn it, you cornfield. I disagree with you. And returns true if the field is blank and false otherwise. When you create a formula, you choose to treat blank fields either as zeros or as blanks. By default, treat blank fields as zeros as selected. You can use ISBLANK to check whether a field is blank if you selected treat blank fields as blanks. Where is that? Treat blank fields as zeros as selected. Come on. I don't know where to see blank fields. Just nice open fields. For custom formula fields, there is a blank field handling section. This section is accessible when you click Edit on the formula field within Setup. Is in used if your formula references any number, currency, or percent fields. You can specify what happens to the formula output when their values are blank. So, if I go back to what was it? Interest rate? Okay. This is like right at the bottom of this page. It might be cut off. So I do this. It's a little bit unelegant, but okay. If your formula references a number, currency, or percent field, specify what happens to the formula output when their values are blank. So here I have treat blank fields as blanks and treat blank fields as zeros. So we're going to do blanks as blanks. So then I mean, I should be able to say is blank. I mean, this is what I think I should be able to do, right? That's the expression. Takes the field as an argument. So then I can get rid of this guy and say, basically, if principal custom principal is blank, then do nothing. If not, then do the if statements. But that's not going to work because you get into this syntax circle where I just don't know what I'm doing. It's like I make extra stuff. Yeah, whatever. Okay, we're not going to try that. Okay. So bottom line is I don't know how to use this. I could read this. Going back to that previous example, I would like to be able to check if principal is blank, then do nothing. If it's not blank, then calculate the interest rate. Okay. All right. Hands-on challenge, English, so on and so forth. Your company sells cylindrical hyperbaric chambers. Okay. I would like to know what a cylindrical hyperbaric chamber is. Never come across them before. Is a metal or acrylic tube large enough to hold one or more persons equipped with access hatch that retains its seal under high pressure. Let's go straight to image results. Okay. Cool. Space agey. Nerdy. Medical. Maybe used for transport. You need a formula that calculates the volume of a cylinder for you. Rounded to the wholest near number, given its radius and height. Use the existing mathematical formula for the volume of a cylinder. Phi equals pi r squared times h, where r is the radius of the cylinder, h is the height, and pi is the constant. Pi, yeah. Note, although this formula might be best created on a custom object, for simplicity, we'll create this formula on the opportunity object. Why am I doing this? I don't need this for my job. I don't know why I'm doing this. Create two custom field types. Number on opportunity object. So two custom fields. They're going to be a number type. One's going to be radius with the resulting API of radius and height. Then we're going to create a formula called cylinder volume, and the resulting API name be cylinder volume, and should be created on the opportunity object. The formula should reference the custom fields radius c and height c. The formula should use 3.1459 as an approximation of pi. The formula should have 0 decimal points. I actually feel confident, which is making me nervous. We'll see how it goes. Okay. I think I might have done this. So, a couple of things. Just like, you look at here, like radius __ c, and like, probably if you're at this point, this is like already sort of obvious to you, but you've maybe noticed this, but like it sometimes shows up like that. And actually when you create it, the field label is this, the field name is this. You obviously you don't have to put in the __ c. That just gets added automatically. Whatever. You probably know that. It just struck me that if I was actually copying this, I might have looked for it, but you don't have to add that. But again, if you're at this point, you probably already know that already. I sort of skipped. I created radius, then I thought I was done, and then I went on to create cylinder volume, forgetting to go back to create height. Whatever, that was a stupid mistake. And then the formula should be named cylinder volume, and the resulting API name cylinder volume C, and it should be created on the opportunity object. Here we are on the opportunity object. The formula should reference the custom fields radius c and height c. Okay, so the formula was and the decimal places that it returns is 0. That was one of the things that was important. Formula should have 0 decimal places, 3.1459, and that's the formula. Radius c to the second power times height c. So I think I did this. I'll find out. I really don't know math though. Okay. There was an unexpected error in your org, which is preventing this assessment check from completing. System DML exception insert failed. First exception row 0. First error, required fields missing. Required fields are missing discount percent and discount percent C. You need a formula field that calculates the volume of a cylinder for you, rounded to the nearest whole number given its radius and height. Use the existing mathematical formula for the volume of a cylinder, where R is the radius of the cylinder, H is the height, and pi is the constant, pi. Now, although this formula might best be created on the custom object, for simplicity, we'll create this formula on the opportunity object. Create 2 custom fields of type number on the opportunity object. Number. Number. The formula should be named cylinder volume. The formula should reference the custom field's radius c and height c. The formula should use 3.1459 as an approximation of pi. 3.1459. The formula should have 0 decimal points. 0. Required fields missing. Required fields are missing. Discount percent. Custom field. Sure don't know where discount percent custom field comes in. Well, yeah, it's not there, but where should it come up? Not mentioned anywhere else in here. I'll try running the check again. We're going to pause for a second. Okay, I just tried signing out, signing back in. Yeah, okay. Alrighty. Don't know what to do about this. I'll be back. Okay, so here I am at the Ford service station, and I'm just going to complete this real fast so I can start exporting this video while I wait. So basically, the Trailhead team got back in touch with me. I asked them why I was getting this error, and they said that I added a custom field, which I guess I did, because I was trying to actually do some of the exercises, I guess earlier in the unit, and that sort of messed me up. So go to Setup Object Manager, choose Opportunity, Fields, and then Edit Discount Percent, and Uncheck Required. So let's go do that. So we're over here, Fields, and Discount. And uncheck required. I think I need to edit that. And then save. Let's see, did I do it right? Let's go back. And uncheck required. Okay, and then they close this. So now, let's see. That should work now. Hopefully. Unless I created something else that I also put as required. But now I know how to read this. Okay, cool. Thanks for watching.